Okay, thanks everyone for coming to this session. So today we're very pleased to have Katie Elliott. So Katie is currently a professor at UCLA. She has done amazing works on chance, explanation, and prediction. And I just learned that this paper on which the talk is going to be based on is forthcoming in Synthesis, and I strongly encourage, I think it is on Synthesis, you should correct me if not, but anyway, I encourage everyone to check it out, and I'm going to read it immediately after this talk anyway. And I also learned from Katie that she's working more generally on a book on chance explanation. So without further ado, Katie, please feel free to take it away.
Thank you so much. No, I'm really looking forward to this. Normally, I wouldn't waste your time trying to get you to talk to me about a paper that I was already out, but this material is going to play a relatively large role in a book I'm working on. And so I very much still need help with this stuff and feedback on this stuff. So yeah, really, really valuable for me. The title of this talk, as you can see, is Where Are the Chances? In retrospect, that's not a great title. It's both a rhetorical and metaphorical question. So who knows what I'm even talking about? But let's try to get into it and figure out what's going on. Okay, so I want to basically frame the subject of the talk around a question that people have been thinking about. Sometimes people describe this as a question of whether or not there could be chances in a deterministic world. So what I've got here for you is a indeterministic causal process. It's obviously my hand. I don't know if you've seen my hand, and it's exactly what that looks like. It's a hand flipping a quarter or whatever. The flip happens at T1. The quarter flies through these clouds. It's a sunny and cloudy day, but that's irrelevant to the project. I'm new to slide making. I got really excited. Anyway, the coin flips end over end and finally lands on heads at T3. We have two different theories here that have probabilistic content. This first theory says that the probability of heads is 0.5 at T1. The probability of heads is 0.2 at T2. And then finally, when the coin lands heads, the probability of heads is 1. And this other theory is supposed to be a fundamental theory on which the world is fundamentally deterministic, and it assigns probability 1 to each one of these microstates that's a realizer of heads. So it says functionally the probability of heads is 1, the probability of heads is 1, the probability of heads is 1 the whole time. Okay, so the question that I want to ask to begin with is, what are some ways to make these two theories consistent? And there's like lots of ways of making these two theories consistent that aren't remotely sort of interesting and that will be familiar to all of you. So one way these two theories could be consistent with one another would be for the probabilities at the bottom here to model chance. I'm going to talk about chances in this paper. By chance, I don't want to be committed to anything more than objective, probability. I mean, one of the things that's sort of at stake in the talk is what are kind of the essential features of chance. Many people have thought that an essential feature of chance is described by the principle. I don't want to be too committal here, but like I'm trying to talk about the kind of thing that Lewis is talking about, but maybe not take on everything about chance that Lewis takes on. So hopefully you know the kind of space that I have in mind when I talk about chances. Right, so it could be that there are chances down here, and what these probabilities are doing are modeling chances. And what these probabilities are doing up here is modeling something else, some other kind of feature of the world. So it could be maybe they're modeling frequencies. It could be that they're modeling the actual doxastic states of some agents. It could be that they're modeling idealized doxastic states. If any of that is going on, there's no even like apparent tension between the truth of these two theories. So that's totally fine. Also, nothing that I've said so far suggests that the situation is asymmetrical. So it could be that the top theory models chance and the bottom theory is modeling something about frequencies or attitudes or something. So that's for everything I've said so far, no problem. But people have wondered whether or not there's a problem with this setup. So could it be, did you see those flames? Those flames are awesome. Could it be that the top theory is modeling chance, while the bottom theory is also modeling chance? That is, could there be non-maximal chances in a world that's fundamentally deterministic? If you think the answer to that question is absolutely not, I'm going to call you an incompatibilist. And if instead that situation seems totally fine to you, I'm going to call you a compatibilist. Okay, now maybe you think that our world isn't fundamentally deterministic, and so you're not terribly interested in this question. But of course, the deterministic version of this question is just sort of a limiting version of a more general question we can ask about how the fundamental chances have to relate to the non-fundamental chances. So in particular, could it be, say, that theory 2 here assigned 0.9 to all of these microstates, while theory here assigned 0.5, 0.2, and 1 to this macrostate, have them both be interpreted as modeling chance? Is that a possibility? In other words, could there be a world in which macro chances are relatively autonomous from micro chances? That's the kind of general version of the question for which the deterministic chance is sort of a specific version of that question. So once again, if the answer for you is nope, you're going to be an incompatibilist on my terminology. And if the answer is sure, no problem, you're a compatibilist. Okay, so one way of trying to decide between compatibilism and incompatibilism seems like it would be to sort of figure out when the probabilistic content of a theory is best interpreted as modeling chance as opposed to modeling something else. In other words, it seems like if we could answer this question, we could get some traction on this other question about incompatibilism and compatibilism. So the question we're now focused on is, how can you tell whether the probabilistic content of a theory models chances or something else? And it's that question that I'm sort of metaphorically expressing in shorthand as the question of where the chances are. So how can you tell where the chances are, whereby where they are, I mean both how can you tell whether there are any chances at all in your world, but also how can you tell if the chances are macro or micro or exactly sort of where they are? In other words, if you've got a probabilistic theory of the world, how do you know what parts of it to slot in as being about chances? So that's sort of our question. Here's the outline for the rest of the talk. I think you find in the literature roughly 2 dominant strategies or guides for figuring out where the chances are. I think some people think you should look to the explanatory properties of theories to figure out where the chances are. And I think some people think you should look towards the predictive power of theories to figure out where the chances are. And I also think that typically people who like this strategy tend to be compatibilists, though I'm going to want to push back on that a little bit. And people who like this strategy tend to be incompatibilists, though people like Barry and Luke Glynn are going to want to push back on that idea too. After we look and talk through these 2 guides, I'm going to give you an alternative picture of the structure of scientific explanation. It's this thing that I'm trying to argue for in this book I'm writing. And one of the ways I'm trying to argue for this alternative structure is by trying to show that there are various theoretical goodies you can get if you buy onto this structure. And I think one of the theoretical goodies you can get is an alternative is an implication about what the relationship is between these 2 guides and which of these guides is correct. But we'll sort of get there eventually. Okay, starting out with explanation as a guide to where the chances are. Everything relatively cool so far? Just setup stuff? Okay, great. Okay, so to try to start motivating the idea that explanatory considerations might be useful as a guide to when the probabilistic content of a theory models chances. Let's start with some kind of platitudinous observations. First one, at least typically my epistemic attitude towards some chance outcome, some event O's occurrence, that does not typically help to explain why event O occurred. So just to have some cheap examples, why did it rain? Oh, because I was pretty sure it would. That sounds bad. Why did it rain? Well, given my evidence, I should have thought that it would. That sounds bad. So it seems like facts about just our actual doxastic attitudes or what our doxastic attitudes should be don't typically straightforwardly explain. Now, I don't want to deny that you might be able to cook up some complicated analysis of chance in terms of doxastic states and then make some complicated argument that those really are explanatory. Maybe you're a deflationist about explanation or something. I just mean like prima facie, intuition level, it doesn't seem like our doxastic states are the kinds of things that are appropriate for explanation. Next, it also seems like the frequency with which events like O occur doesn't typically help to explain why O occurred. So why did it rain? Well, because among days like today, 80% of them were rainy. That also seems bad. Again, I don't want to deny that you could cook up a relatively sophisticated analysis of chance in terms of frequencies, a la many different flavors of Humeanism, and come up with something that was genuinely explanatory. I just mean that it's not typically the case that any old frequency can be used to explain a sort of instance of the frequency. However, at least prima facie, the chance of O's occurrence does typically at least help to explain why O occurred. Of course, you could deny this, but I just mean that it doesn't sound bananas to try to refer to the chance of O in an answer to why some chance outcome occurred. Okay, but that, so here's an example of that. So why did roughly half this sample of radium-226 decay after 1600 years? Well, because the chance that a radium-226 atom decays within 1600 years is 50%. That doesn't sound bananas. I mean, maybe on reflection it's wrong, but at least pre-theoretically that sounds okay. Okay, these kinds of considerations, the idea that one of the kind of markers of being a chance as opposed to being a frequency or a doxastic attitude is your explanatory potential, those kinds of considerations have motivated, I think in the literature, something I'm going to call good explanation test. No one explicitly endorses good explanation test, but I think lots of people say lots of things that imply something like good explanation test. Okay, so if a sentence of the form, the probability of O is equal to N, is a non-eliminable part of a good explanation of O's occurrence, then the sentence is true, and the probability ascription is about O's chance of occurring. I think, for instance, stuff that Luke Lin says implies this. I think Nina endorses this, at least in the 2013 piece. What's the non-eliminable thing doing? That's the idea is just that you don't want something to count as being part of a good explanation if it's not doing any work, so to speak. So the idea is just if you took that sentence out of the explanation, if the explanation would get worse, then that sentence is a non-eliminable part of the good explanation. Okay, so whatever you think about good explanation test, I think it is compatibilist friendly. I think that it's relatively intuitive to lots of people that even if the ideal explanations all happen at the fundamental level, that you get some good explanations at the macro level. So maybe the ideal explanation of the coin landing heads always has to do with these maximal microstates. Still, it seems like you learn some pretty decent explanatory information when you find out that the probability of heads started out as 50%, then it went down, but then things turned around and we ended up with heads. Not only do I think it's sort of pre-theoretically hard to deny that there are good explanations at the macro level, I think when we start looking sort of more seriously at actual scientific examples, the pressure is even more serious. So for example, Evolutionary biologists seem to make use of probabilities when they explain the frequency of a given trait among a population, at least in part, by arguing that the trait contributes to an organism's overall fitness. Let's take another example. Strevens argues that the wide acceptance of stat-mech in the 19th century is because of its explanatory power, because of the explanatory power of its specifically probabilistic content, despite the background being that stat-mech is compatible with determinism. So I think once you get the compatibilist to admit that you don't get ideal explanations at the macro level, you just come off like a jerk to deny that there are even merely good explanations in evolutionary biology, say, or in stat-mech. So I think if good explanation tests were true, then the dialectical situation for the compatibilist would be pretty solid. But there's a problem, and the problem is just that there are way too many plausible ways for probabilistic content to be an important part of a merely good explanation without thereby being true and about chance. So I'm not going to bore you with all of the various ways that this might happen, but just sort of point you to two prominent ways discussed in the literature. One is from Kitcher, 1989. So Kitcher argues that Kitcher is thinks that there aren't any explanations in indeterministic contexts. So he's got to do a lot of stuff to make that palatable. He argues that probability ascriptions of 1 or 0 that are either false or not about chances might nevertheless be explanatory in virtue of being about idealizations of indeterministic phenomena. A similar move is available to us in this context. So we could argue that probability ascriptions between 1 and 0 that are either false or not about chance are explanatory in virtue of being about idealizations of deterministic phenomena. So maybe perhaps thermodynamic probabilities arise from the idealization that a system's initial conditions are chosen by genuinely stochastic processes rather than merely being unknown to us. So that would be a story on which probabilities could be doing something importantly explanatory without being true and about chance. Or for another story, we might follow Railton's 1989. So Railton says that, look, probability ascriptions that are false or not about chance can nevertheless be explanatory by being evidence about the content of the ideal explanatory text. So Railton argues that the probabilities of thermodynamics can be explanatory, even if they're artifacts of combinatorics rather than genuine references to chance. He writes, such appeals to combinatorics serve to illuminate a significant feature of the causal process underlying the behavior of classical thermodynamic systems. This sort of causal process is such that its macroscopic outcomes are remarkably insensitive in the limit to the wide variations in the initial microstates. So all that's going on here is we're just getting another story about how you could have probabilistic content that either was strictly speaking false or that wasn't trying to model chances that nevertheless played a role in a pretty good probabilistic explanation of some kind of phenomena. So I think good explanation test is probably false, but I think ideal explanation test still has a lot going for it. So ideal explanation test just raises the bar on how good your explanation has to be. Ideal explanation test says, if a sentence of the form, the probability of event O is equal to real number n is a non-eliminable part of an ideal explanation of O's occurrence, then the sentence is true and the probability ascription is about O's chance of occurring. Now, what do I mean here by ideal explanation? I mean sort of ideal explanation in the sense of Railton's ideal explanatory texts, where the idea is sort of, you have one kind of informational structure that includes all the information that your theory of explanation says you need to in order to explain the explanandum. So all that stuff gets put into the ideal text, and then acts of explanation are more or less adequate depending on how, relative to a particular context, they convey information about the ideal text. So for Railton, the ideal text is enormous, but you don't have to think the ideal text is enormous to have this distinction between the ideal text and an active explanation. And so ideal explanation test basically says, if in your ideal text, a probability ascription appears, then that is sufficient to think that that probability ascription is true and models chance. Okay, I think Railton implicitly endorses ideal explanation test. I think Jonathan Schaffer implicitly endorses ideal explanation tests, maybe other people too. Later, I'm going to argue for ideal, or at least I'm going to show that ideal explanation test follows from this view that I like. I'm not going to argue for the view that I like, but I'm on board with ideal explanation test.
Is this an okay to ask a question?
Yes, very much so.
Okay, so thanks. That's super interesting. I had another thought. At first, I thought I was going to ask it and say like maybe this is a worry, but now I actually think it might be in support of what you were saying. So I was thinking some probability ascriptions can be best understood as typicality claims. So you say this has probability 0.99 of occurring, and you say that using like a probability measure. So it is a probability claim. But maybe there are independent arguments for thinking that probability claim is best understood as saying like typically the gas expands, or typically this is how this type of Bohmian configuration evolves. And then some people think typicality claims are distinct from probability claims. And then that was gonna so that would be a reason to think the good explanation test is that would be another reason to think it's not correct, because this would be an example of one of these sentences that takes that form, but it's not an ascription of a chance occurring. It's an ascription of a certain typical event occurring, and assuming that those are distinct, then that would be a potential counterexample. And then I was thinking, but that wouldn't be a counterexample to your ideal explanation test, because maybe typicality claims are like explanatory only in some non-fundamental derivative sense. So like at the fundamental level, you could still have only chances or something. Anyway, sorry, I was just wondering what you think of that.
I think that's all super interesting. So I just want to say that like I haven't thought a lot about this, and I think it would be really cool to try to think about whether or not there were good reasons to think that the typicality stuff should appear in the ideal text, and so counterexample this test as well as the good explanation test. But I totally agree with you that like the first rhetorical move for me to make is try to argue that like the typicality stuff is all on the good explanation side, but not on the ideal explanation side. But I just want to be totally honest, like I just haven't thought about it. And that's a good, fun challenge to ideal explanation, at least a potential fun challenge to ideal explanation tests too. So yeah, it's super helpful. Thank you. Good. Great. Okay. Okay, so I think that ideal explanation test is plainly less compatibilist friendly than good explanation test. Because while you'd have to be, I think, in a very grumpy mood to deny that this up here is a merely good explanation, it's not so obvious that this is an ideal, that these are, non-competing but distinct ideal explanations of the coin's landing heads. And it's also not obvious that you get ideal explanations in non-fundamental sciences. So I think it's much more plausible to argue that non-fundamental sciences give you less than ideal explanations than it is to argue that non-fundamental sciences give you not even good explanations. And so ideal explanation test, the move from good explanation test to ideal explanation test is a rhetorical loss for the compatibilist. But it's not rhetorical game over for the compatibilist, because of course the compatibilist can just say, all right, I'm going to argue that there are ideal explanations up here. And certainly there's a tradition that argues that. I think Nina's part of that, at least sometimes part of that tradition. I think Putnam is an obvious example of something in that space. But so it's not like I'm saying this is game over for the compatibilist, but it does make the compatibilist life harder. Okay, now if you're an incompatibilist, you can't just chill out with ideal explanation test here, because all you've really done is make the compatibilist life harder. But now she's going to try to argue that whatever, there's ideal explanations all over the place. You'd love to have another kind of tool to whack her over. This is weirdly violent. Why am I saying it like this? You'd like to have another sort of tool to like, bolster your incompatibilism. Oh, sorry. this is not good presentational. Okay, let's pause here. I was about to immediately launch into the second section, but let's pause at this section, see where we've come. We had one guide to where the chances are, and it seems like the version of this guide that we think is best is the ideal explanation test version. But as I was just explaining, people who are incompatibilists argue for a different guide to sort of shore up the case for incompatibilism. So now we're ready for section 2, prediction as a guide to where the chances are. Okay, so now let's forget the levels, let's back up and let's think about what the connection is supposed to be between prediction and chance. Here's a question. At T1, what are the best grounds one can have for one's expectations about whether the coin will land heads? So if we lived right here, what would be the best grounds we could have to base our expectations about the future with respect to heads on? What would be our best grounds? And so long as we ignore inadmissible evidence, this is using terms of art from Lewis, but so long as we ignore like fantastical kinds of evidence, it seems like there are no better evidential grounds for our expectations about whether or not the coin is going to land heads than the chance of heads at T1. So if we live at T1, the best grounds for our expectations about whether or not the coin lands heads are those T1 chances. So I think you can find this idea all over the place, but Bishop Butler, Wesley Salmon, sort of our prefigure Lewis, and then of course Lewis, very famously with the principal principle, puts forward an idea that's going to imply something like this. Okay, so in particular, what's going to be important for our purposes is that the conjunction of the state of the world at T1 and the totality of the natural laws, those are not better evidence about whether the coin is going to land heads than is the coin's chance of landing heads at T1. So it seems like part of the predictive role of chance is that it's not going to get outdone by the natural laws combined with the state of the world at T1. Okay, well, if all that is right, then that motivates the following test, which we're going to call laws and present conditions test. It says this: if a statement of the natural laws and a description of the present state of the world is better grounds for our expectation that event O occurs than is a sentence of the form, the present probability of O is equal to N, then either the sentence is false or the sentence is not about chance. So,
Katie, can I ask you something?
Yes.
What would you say about a theory like Bohmian mechanics?
I don't yet know what the question. Can you ask the question slightly different or explain more?
A theory in which there are probabilities, but there's a state of the world which is inaccessible, literally cannot, according to the theory, cannot be known, which would be better, would specify what will happen. It's a deterministic theory, but there are probabilities, and the best we can do is the probabilities are eradicable.
I see. I mean, so one thing that's going to emerge from this discussion is that I'm going to end up with like a kind of functional account of admissibility. I mean, I don't like talk about it that way, but like basically what's going to happen is that like explanatory relations are going to determine like what information counts as admissible or inadmissible. And I don't know what the explanatory status is of the theory yet. So I don't know how to answer whether I'm going to try to claim that like, oh yeah, I can still preserve this claim, but I'm just going to shove off some of that stuff as being inadmissible. Does that make sense, Barry?
Not yet, but maybe when I see how you develop the idea, it will.
Let me do a little bit more and then re-ask that question maybe.
Mm-hmm.
Okay, great. Okay, so I think Lewis thinks something like this test is correct, and I think Schaffer thinks something like this test is correct. So for instance, I think Lewis thinks that this is a consequence of the principle and some claims about what's guaranteed to be admissible. And I think Schaffer thinks this is true too. Okay, but laws and present conditions test, it's prima facie incompatibilist friendly. So to see that, notice that suppose you're here at T1, the probability of heads is 50%. Should you use this as your best grounds for making a prediction about the coins landing heads? The answer is no. If the world is deterministic, then the laws and present conditions are going to be better epistemic grounds than are this thing for your predictions about heads. And so laws and present conditions test implies that this thing is not a chance, or it's false. Shouldn't be interpreted as a chance, or it's just false. Whereas this thing down here, this thing is not beaten out by the conjunction of the deterministic laws and the present state of the world. This thing is just as good epistemic grounds as are the laws combined with the present state of the world. So this thing is not ruled out from being a chance by our test. And so this all motivates incompatibilism. Okay. Problem. While it's arguably true that the principle and sort of standard accounts of what counts as admissible information imply laws and conditions test, you could instead take the principle plus a kind of level relative account of admissible information to motivate a compatibilist friendly prediction-based test. And I was thinking this is what Barry does. And I was thinking this is what Luke Glynn does too. So just come up with like versions of the principle by restricting admissibility to a level in some way. And then that will motivate not laws and conditions test, but instead this thing that I'm calling macrophysical laws and macrophysical conditions test. Here, the idea is basically that all the chance needs to do is screen off the stuff at its level. It doesn't have to screen off stuff at every level. So here's the test. If the content of the macrophysical natural laws and the macrophysical description of the present state of the world is better grounds for our expectation that event O occurs than is a sentence of the form, the present probability of O is equal to N, then either the sentence is false or the sentence is not about chance. So this is just the sort of macrophysical version of the laws and present condition test. Okay, and the macrophysical version is compatibilist friendly, right? Because now the probability here only has to not be beaten out by the macro laws and macro conditions, but presumably the macro laws and macro conditions imply this probability. And so presumably we're all good here and we're all good down here. And so compatibilism is back on the table. Even if we endorse a prediction guide, we can still be compatibilists by using Barry and Glynn's strategy. Okay, so where are we after section 2? Where we are at section 2 is it seems like we have two prediction-based tests. We have the laws test and the macrophysical version of the laws test, but we need some kind of non-arbitrary, non-question begging reason for picking between the two of them. And I don't think there's obviously such a reason already presented in the literature. I mean, you need some kind of non-arbitrary justification for restricting or not restricting admissibility. Everyone has to restrict admissibility in the sense that, you can't say that every fact is an admissible fact. Otherwise, we're going to immediately trivialize the project. But of course, you can't restrict admissibility. You can't have, almost nothing be admissible, because then you're going to, trivialize, you're going to have all kinds of probabilities turn out to be chances. So there's some kind of like sweet spot with respect to admissibility, and you'd like some motivation for where that sweet spot is that doesn't beg the question against either the compatibilist or the incompatibilist. Okay, now we're ready for a sort of change of topic, which is that I want to give you a non-orthodox picture of the structure of scientific explanation in indeterministic contexts. And then later I'm going to use that picture to draw out some morals about how these tests work. Okay, here is the picture. So I want to suggest that when an event occurs by chance, the total ideal explanation of the event's occurrence is its chance of occurring. Now, there's some complications here having to do with the time at which the chance event occurs, but I'm going to push those off for now and try to do this just all atemporally. But if you have questions, of course, no problem. So, okay, so the idea is going to be the event's chance of occurring. So every time, let me start again. Every event that occurs by chance has an ideal explanation. The ideal explanation is its chance of occurring. And that's true regardless of the size of the chance value. So whether or not the event was very unlikely or very likely, it has an explanation, and it is its chance of occurring. Then we can also ask, so we can ask, why did the coin land heads? And the answer is, well, the coin had a 50-50 chance of landing heads, say. We can also ask, why did the coin have a 50-50 chance of landing heads? So I think a fact like this also has a diachronic scientific explanation, or at least a scientific explanation. The reason why the chance of heads was n has to do with the laws, antecedent conditions, causes. So we say, look, why did the coin land heads? Its chance of landing heads was 50%. Why was the coin's chance of landing heads 50%? Well, maybe the coin was evenly weighted. The conditions were as follows. The laws governing the evolution of the coin are as follows, blah, blah, blah. All that stuff on my picture helps to explain the chance of heads. The chance of heads explains the chance outcome, but these arrows are intransitive so that you can't skip this middle part. So you can't go directly from back here to here. These things are explanatorily relevant, but they're always mediated by the chance value. So these things back here explain this thing, and this thing here explains this thing, but it's not the case that this thing gets to leapfrog the chance to directly explain the chance outcome. Okay, so again, this is ideally explains in the sense of Railton's text. The size of this chance value is totally irrelevant. These arrows are supposed to be intransitive. Oh, and the last thing to note is that this explanandum is supposed to be a non-contrastive explanandum. So we're not explaining, say, why the coin landed heads rather than tails. We're just explaining the non-contrastive fact that the coin landed heads. Why is that? Well, I think that when unlikely events occur, you often can't give contrastive explanations of their occurrence, but I don't think we should infer from that that you can't give non-contrastive explanations of their occurrence. Okay, so this is a picture I'm going to present to you. I'm going to give you no motivation for this picture whatsoever, but I do want to point out that many elements of this picture are precedented. So the idea that the size of the chance value makes no difference to whether or not an event is explicable is common, though not universally accepted. It's common to think that the laws or causes or antecedent conditions, that gnomic stuff plays some important explanatory role in our scientific theorizing. The most sort of unorthodox part of the picture is just that I'm carving up different distinct explanatory roles for items of scientific theories in a slightly different way than they're normally carved up. But the kinds of things that are doing explanatory work on my picture are also doing explanatory work on many other pictures. It's just that they're not typically structured in the way I'm structuring them. Okay, so I try to argue that one nice feature of this structure is that if this structure were correct, it would help us to understand. It might be what makes it the case that chance has its characteristic predictive structure. So here's a conjecture. If X is the ideal explanation of P, so you've got something that's the ideal explanation of some proposition, then X has got to be at least as good grounds for your expectations in P, for forming your expectations in P, as is information that's explanatorily antecedent to X. Now, explanatorily antecedent to X for me is a technical term. It just means that the stuff explains X without also explaining P. So if you explain X, but you don't leapfrog to P, you're explanatorily antecedent to X. So basically the idea is just that we have a chain of explanation, P, X explains P, and then some other stuff explains X. Everything that's anywhere back here in the chain is explanatorily antecedent to X. And then the conjecture is that if X is the ideal explanation of P, then X is at least as good grounds for one's expectations in P as is any information that's explanatorily antecedent to X. So basically what this says is like, suppose you only have explanatorily relevant information to go on, and you have to form some impressions about whether or not P is going to occur. The best you can do is by forming your expectations in light of the most immediate explainer of X. You'll never do better by forming your expectations by using more immediate explanatory information. Of course, there might be non-explanatory information that's way better evidence. We're only talking about information that's structured in this explanatory chain. And what the conjecture says is that the immediate explanatory information is better evidence about the explanandum than sorry, let me try again. The immediate explainer is as good of evidence about the explanandum as is anything that's an explanation of the immediate explainer, that is, that's further back in the explanatory chain. Okay, I don't have any argument for that. It's a conjecture. I think it seems relatively plausible to me. It doesn't seem totally bananas to me. But if it's right, then we can go from this explanatory structure to the characteristic predictive structure of chance that I've been describing to you in section 2. So have X be that the chance of heads is equal to N, have P be this chance outcome, and have this stuff all be explanatorily antecedent. Then this conjecture says that this stuff should be at least as good evidence about whether or not P is going to occur as is any of this stuff back here. But that's exactly the structure of indeterministic best grounds for predictionness. So it really is true that the chance of heads is as good of grounds for your predictions about the chance outcome as is any of this stuff back here. Where again, that this stuff is back here. It's back here in virtue of helping to explain this. So if that explanatory structure is right, and if this conjecture is right, then we just get the exact mirrored predictive structure. But the predictive structure is the predictive structure we're supposed to get, and so this would be a way to try to explain the characteristic predictive profile of chance by using my claims about its explanatory structure. So I'm trying to recover the characteristic predictive structure of chance from some explanatory structure, and this conjecture is supposed to be connecting the two. So at the end of section 3, we get a picture on which chance's explanatory structure is supposed to be securing at least an element of its predictive structure, the kind of screening off element of its predictive structure that we've been talking about. But now that alternative picture has something to say about all these guides to where the chances are. So here's how that works. Start with this question. Could there be more than one ideal explanation of an event's occurrence? Suppose you say the answer is no. Well, on my picture, if there's only one ideal explanation of an event's occurrence, it has to be the chance of heads. Okay, so we've got this. There's no other, we've already just fixed that there's no other explanation, so there's only one route through here. My view says that the chance of heads should screen off then everything that's explanatorily antecedent to it. If there's only one explanatory path, all this stuff is going to be explanatorily antecedent to it. And so if there's only one ideal explanation, we get a vindication of the laws and conditions test and a vindication of incompatibilism. So if you've got my picture of the structure of explanation, and if you answer this question with no, then you get a vindication of the laws and conditions test and a vindication of incompatibilism. What happens if you answer yes? There can be more than one ideal explanation of an event's occurrence. Okay, well, there's actually two cases that we now need to think about if we're thinking there can be more than one ideal explanation of an event's occurrence. One case has the explanatory chains, the separate ideal explanation chains, has them being completely separate, non-overlapping. So there's a sort of macro explanatory chain to the chance outcome, where the macro laws and macro states explain the macro chance of heads, and then the macro chance of heads explains the macro outcome. And then on a separate chain, the microphysical laws and microphysical states explain the microphysical chance, which then also helps to explain the chance outcome. And so we have two separate explanatory chains. If that were the picture, then the relevant question would be, okay, if we've got this explanatory structure, are there any constraints about what values we can put in here for the chance values, right? Incompatibilists think that there have to be constraints between these two things. Compatibilists think there don't have to be constraints between these two things. And so we're going to try to figure out, on my view, which should be the right answer. And I think it depends. It depends on whether or not you think this. So I conjecture that it's not the case that we sort of have any independent reason to think that ideal explanations of a single event have to be equally good evidence about whether that event occurs. Of course, if we were like Hempel, then we would deny this, because we would think that, like, there's only pragmatic differences between prediction and explanation. But I think most people don't think the connection between prediction and explanation is so tight that in order for there to be two equally good explanations, they also have to be two equally good predictive bases. And so I think at least a lot of people will be okay with this conjecture. But if this conjecture is right, then we can fill in these values with these flames in any old way we want. They could be the same value, they could be different values, it just doesn't matter. But if that's right, then we've got vindication for macrophysical test, because the chance of heads here, it has to screen off everything that explains it, but it's only explained by the macro laws and macro states. The microphysical chance, it screens off everything that explains it, but it's explained only by the fundamental stuff and the microstates. The two paths don't connect. And so we have motivation for thinking that this screens off this and this screens off this, but we don't have any motivation for thinking that this has got to screen off this. And so we don't have any motivation for laws and conditions test, but we do have motivation for macrophysical test. So case one, separate explanatory chains. Two ideal explanations. My picture seems to imply that macrophysical test is true, but it seems to give no motivation for laws and present condition test. Of course, it doesn't imply that laws and present condition test is false, but it doesn't give us any reason to think that it would be true. Second case, what about if you have overlapping explanatory chains? So here's a thing that doesn't seem totally bananas to me. You might think that the fundamental laws and microstates help to explain the microchance, but you might think those very same features also help to explain the macrochance. So why is the macrochance of heads 0.5? Well, because the fundamental laws are such, and because the various micro-realizers of the coin are symmetrical in various ways, say. If you have that kind of picture, then we need an additional conjecture to kind of handle this case. Here's what I think is the right thing to say about this case. I think the right thing to say about this case is that my picture doesn't give any motivation for thinking that the macro chance has to screen off this stuff when we've got overlapping explanatory chains. And the reason why is as follows. Since this micro stuff is evidentially relevant to whether the coin lands heads, in virtue of helping to explain both the macrophysical stuff and the microphysical chance of the coins landing heads, then the micro stuff might be better evidence about whether the coin lands heads than is either of the ideal explanations of the coin landing heads on its own. So I was thinking like the macro chance has to like screen off the evidential contribution along the macro chain, but it doesn't have to screen off the evidential contribution along the micro chain. And symmetrically, the micro chance, if the micro chance were explained by the macro laws, then the micro chance would have to explain everything that's just, would have to screen off everything that's just on this chain, but the micro chance wouldn't have to screen off things that are on this chain and this chain. In other words, if you just flipped this diagram, everything would be the same. So basically my thought is, if you've got a picture where the fundamental laws explain both the macro chance and the micro chance, you shouldn't expect the macro chance to screen off the fundamental laws, because the fundamental laws are getting their evidentiary grip on the chance outcome through two explanatory paths rather than just one explanatory path. You should screen off everything as it were sort of on your explanatory path, but if there's something that's on two explanatory paths, you shouldn't be expected to have to be able to screen off something that appears on multiple explanatory paths. Okay, so if that's right, then the macrophysical chance of an event is as good evidence about whether the event occurs as is the macrophysical stuff, but the macrophysical chance of an event doesn't have to be as good evidence about whether the event occurs as the microphysical stuff, because the microphysical stuff gets evidentiary purchase through this other explanatory chain that isn't screened off here. In other words, once more, on my picture, we've got vindication for macrophysical test, but no motivation for laws and conditions test. So I think that if you think the answer to this is yes, and you've got my picture of the structure of scientific explanation, then you've got a vindication for the macrophysical test and compatibilism, and you're going to need some kind of additional motivation for incompatibilism. In other words, in sum, I think that my view of chance's role in scientific explanation sort of gives us a principled way of adjudicating between laws and conditions test and macrophysical test. If we decide there's only ever one ideal scientific explanation of an event, my view is going to underwrite laws and conditions test and also incompatibilism. If we think there could be more than one ideal scientific explanation of an event, and if we also think that non-competing ideal scientific explanations need not be equally good grounds for expectations about the event they explain, then my view motivates macrophysical test, but not laws and conditions test. So I think my view of chance's role in scientific explanation gives us a reason for choosing between laws and conditions test on the one hand and macrophysical test on the other, that doesn't obviously beg the question against either the, that should say, compatibilist or the incompatibilist. At least that's what I'm hoping. So if I think if my alternative picture is correct, then the answer to the question, where are the chances, is that the chances are wherever the ideal probabilistic explanations say they are, and that will vindicate both the explanatory and predictive profile of chance, and so give you a kind of non-question begging way of figuring out whether you should be an incompatibilist or a compatibilist. At least I think. I got really into that flame effect at the end. That's the end of my talk.
Thank you so much. Please feel free to unmute yourself and give Katie a round of applause.